Check 1, 2, check 1, 2. All right, lesson 92. There, okay. Dividing by two-digit numbers. In this lesson, we will begin dividing by two-digit numbers. Dividing by two-digit numbers is necessary to solve problems like the following. 144 players signed up for soccer. If the players were separated into 12 equal teams, how many players would there be on each team? That, my friends, is a real-life problem that someday you might need to solve. And so this is a very interesting and very useful skill to have. You need to know how to divide by two-digit numbers. So we're going to learn today. When we divide by two-digit numbers, we continue the following 4 steps of division. The steps to division are divide, multiply, subtract, and bring down. When we divide by two-digit numbers, the divide step might take a little bit more thought because we have not memorized all the two-digit multiplication facts. So the first thing we're going to do is start with an example. 150 divided by 12. We have to begin, of course, by writing our division problem set up. It's going to be set up like this, 150. So 150 divided by 12. We begin by breaking the division into a smaller division problem. Starting from the first digit in the 150, we try to find the smallest number that 12 will go into. So does 12 go into 1? No, it does not. So I personally put a little X over the 1 so that I know that it's not going to be a 3-digit number. So now I only have 2 digits left that it could possibly be. Does 12 go into 15? Yes, it does. 12 will go into 15 one time, and you're going to have 3 left over. We see that there are 12 into 15 1, so we write a 1 above the 5 in the number 15. Then we multiply, subtract, and bring down. So for this one, we didn't really need to multiply because it's just one time. Subtract, and then bring down. So we've got 30. And now we have a new division problem. This time we find how much 12 can go into 30. If we're not sure of the answer, we may need to try more than once to find the number of 12s that can go into 30. We find that 2 12s can go into 30, and that would give us 24, and that is our new subtraction problem. So that is 2 times. So we put the 2 up there, and then we find out that 30 take away 24 is 6. And so we multiply and subtract, and there's no digit to bring down, so we are finished. So the answer is 12, remainder 6. Now, I don't want this to confuse you because we have been working a lot with fractions, and when you have a remainder and a fraction, it becomes like this would become 6 1/50ths. We don't need to do anything like that. And then, of course, you could reduce it to like 3/75 and then 1/25. So it would be like 12 and 1/25. But we aren't going to do that at all. This is talking about, well, we don't know what it was talking about. But anyways, you are just going to have a remainder. So we're back to not fractions quite again. So then we always have to double check our answer. So to check our answer, we're going to multiply 12 by 12 because that's the 2 numbers that we have here. So we do 12 times 12, and we see that that answer is 144. And then we have to add our remainder, and we get 150. And 150 is the same as that number, so we've double-checked our answer, and we know it's correct. Always double-check your answer to always make sure it's correct. All right? So there are some tricks that we can use to make dividing by two-digit numbers easier. One trick is to think of only dividing by the first digit. So that's what I'm going to show you in example 2. We begin by breaking the division problem into a smaller division problem. 32 divided by 98, because 32 can't go into 9 and 32 can go into 98. Instead of thinking how many 32s are in 98, we can use the first digit trick. to see how many 3s are in 9. We see 32 divided by 98, and we can think 3 divided by 9. So 3 can go into 9. That's what we're going to think because we've got this 3 and this 9. So we're going to try the answer 3. 3, we write the 3, 32 cannot go into 9, so we put our little thing there. But 32 can go into 98. And that answer is 3 times. So we put a 3 above the 8 and 98. Then we multiply the 3 by 32 and subtract and bring down. So we have 96. That's 32 times 3 is 96. And we're going to subtract, and we get 2. Then we have to bring this down. So now we have 27. And 32 cannot go into 27. So we have 0 because we know that 32 can go into 987 more. We write a 0 in the answer, then we multiply and subtract, and there are no digits to bring down, so we are finished. So our answer is 30, remainder 27. And of course, we have to double check. 32 times 30, and since that's the 0, we scoot it over like that for that trick, and we get 96, and then that 0, and then we add 27, and we get the total answer of 987, which is the same as that. Double checks it, we are good. Example 3. If a school has 868 students and the principal wants 24 students in each class, how many teachers or classes do they need? Ooh, I added in this word about, which means we are going to estimate. We are going to use compatible numbers to estimate the number of teachers that this school needs. So we're going to round 24 to 20. We could round down 24 to 20, but 24 is closer to 25. So we're going to choose 25. And now we're going to round 868 to a number that's compatible with this number that we rounded to. So that would be 875. And into 875. All right, which we're going to think of as 800 plus 75. And we know 25 can go into 75 3 times, and 25 can go into 100 4 times. So that means 25 can go into 800 much more times. 875 divided by 25 is 35. So there are about 35 teachers needed. Okay, thank you for taking the notes. It's short notes today, and you are going to have a ton of lesson practice to do because it's A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. And yeah, so you're going to do that with your homework, and I hope you have a great day.